So let me ask a question to you. When it comes to hurricanes, whether you're commercial or residential, I don't know enough about them, but what sort of winds are solar panels typically rated to? Is that a hurricane problem, or are they like really well attached?
So that's a great question, and I'm glad that you brought that up. Actually, we kind of touched on it a little bit in last week's session, because last week we talked about racking. Basically, I'm sure you've seen the Florida wind map with the bands that say, what the wind speeds that you need to be designing for, depending on where you live. South Florida, we have to design to withstand 175 miles per hour.
Okay.
Very significant. I mean, my understanding is that's kind of more or less where Andrew wind speeds were.
Yeah.
Yeah. So basically, we are designing for it. Okay. we never install anything without a permit. So before we get to go and install, we have to pull a building permit, which means that the authority having jurisdiction has reviewed and approved our plans. And that could be one of 36 or 38 places in Miami-Dade County alone, and similar number in Broward. So we're talking about all the various municipalities. And so this is something that we're actually very proud of as a company that was born and grew out of Miami-Dade. We have evolved with, in my opinion, the strictest scrutiny in the country as it pertains to, structural considerations, particularly because of hurricanes. So unincorporated Miami-Dade County is probably the most stringent, the most strict, the most particular, the most nuanced. But the lessons learned that we got from there, we've applied everywhere, even if it's Tampa or Orlando. And that's one of the things that we like to kind of advertise when we do sales, even if it's in places like Tampa or Orlando. We're taking the lessons learned in Miami-Dade and we're bringing it here. I've always thought that's very interesting that Miami-Dade has something called an NOA, a notice of acceptance, and that is a pre-approved system for how to install products. Typically, that applies to windows, that applies to roofing. I get asked a lot if that applies to solar. It doesn't. There is no NOA for solar because everything has to be custom designed. But when we design, the number of things that we're looking at is basically every single component in the system. So we're talking about, number one, how are you anchored to the roof? Mm-hmm. And so we're talking about the lag bolts or tap cons if you're embedding in wood or concrete respectively. We're talking about the depth of embedment in the medium. We're talking about the diameter of the lag bolt or tap con. We're talking about the distance from attachment to attachment, what's known as the span distance along the rail. So we do what's called a tributary area method. We figure out the area of solar panels that's to be attributed to one single stand in the worst case scenario. So, we look at wind zones on a roof where wind zone 1 is the center, 2 is the edges, 3 are the corners. We look at what's called an exposure category, which is how high are you, how close to the ocean are you. So we look at all these things. We look at dimension A, which is the width of that wind zone, and then we figure out the pressure that we have to design for. And so, I used the analogy last week that basically the chain is as strong as the weakest link.
Sure.
And you can think of a solar panel system that's attached to a roof like a chain, where it starts actually on the glass surface of the panel itself, because that's the thing that the wind is going to try to suck right out of the panel frame. So panels are rated for pressure in both directions, downward or upward, which is also known as positive pressure or negative pressure, or snow and wind, because snow weighs down, wind pulls up. And of course, we never care about snow. And the weight of the solar panel system itself, what we call dead loads, because they're non-dynamic, they're fixed, is very, very low, right? Even though you think of a pallet of solar panels weighing a lot, they're by nature distributed completely over the entire roof. So a solar panel weighs 80 pounds, and it's approximately, I got it backwards. It's 40 pounds, and it's 18 square feet. So that means that the actual physical weight of the panel itself is about 2 pounds per square foot. So the dead load, the downward pressure, is very, very low. So it's all about the upward pressure. And so, you know, to go back to that chain analogy, it starts from the glass itself, and then it's the panel's frames, the metal frame, its ability to grip onto the glass. And then it goes from the glass frame with something called a mid clamp. That's the clamp that holds it to the rails. And then it goes from that mid clamp, holding it onto the rail, to the rail being held onto the standoff. It's like a 1-inch diameter cylindrical post. And that's the standoff that is then attached to the roof with lag bolts or tap cons if it's concrete.
Mm-hmm.
So that's why I like to use the analogy that it's like a chain that's as strong as the weakest link, starting all the way from the glass that's interfacing with the wind, all the way down to the threads of the screw, the bolt, you know, locking into the medium. That's the concrete or the wooden rafter. And typically the weak point is the solar panel. The industry standard is 2,400 pascals upward pressure. The panels that we use are 4,000 pascals or higher, because this is what we need to be able to meet Florida, you know, code. We're very proud to say that we probably had about 600 or so systems installed throughout the state as of when Irma hit, and they were all pristine.
Wow.
Yep. My business partner, Joe, before opening up the second branch of Goldin Solar, worked in St. Thomas and also put in maybe 100 or 200 solar systems there. And then they had to live through Irma and Maria, and St. Thomas took on Irma and Maria way worse than Florida took on Irma. Maria didn't even pass by her. And our solar systems there did pretty well as well. Now they did sustain some damage, because if there's a flying 2x4 or a coconut or a piece of metal or some kind of debris that's going to just fly like a torpedo right into a panel, that panel will shatter.
Yeah.
But that one panel can be replaced. And so we've got photos of streets where there's houses leveled to rubble, just destroyed, next to houses that we put solar panels on that are still standing strong. And this is something that, you know, we're very stoked about, and you know, make a strong point when we sell solar systems, that if it's a house with wooden rafters, putting solar panels on top of that is like structurally reinforcing the house. It's fortifying the house. Because if you've got rafters running this way and then you put on rails perpendicular, you know, that amounts to like cross bracing. So your rafters are going like that, 2x4s, 2x6s, and you put the rails like that. It's like an exoskeleton. And on top of those rails, we put on panels, which are also, you know, framed this way and this way. It just locks up the house. So when a house wants to rotate and sway and do the things that hurricanes do to houses, the solar panels really help lock it in together. So those joints, those structural joints, stay strong.
Interesting.